So we were started seeing about Hive and how Hive works and what is Hive and why we need Hive. What are the use cases of Hive? Those we started seeing. And Hive is it's not a relational database and it is not for OLTP, and also it is not a real-time query, and it is not used for real-time row-level updates. We won't be able to use Hive for that purpose. So these things we have seen, and we've seen use cases and how it's working in a behind, and those things we have seen, and we started seeing the concepts of Hive, like what is database, how database is getting created in Hive, and what is table, what is managed table, and what is external table, and what is partitions. So any doubts or any idea, like are we able to clear it till now? What is managed table and external table? Can anyone tell?
Yeah, I'm fine with that. Yeah.
Yeah, that's good. Okay, so what is the difference between managed and external table? Any idea? Yeah. Good evening, Ganeshi. So the difference is managed table. If you delete the table, the data also will get deleted. If you delete the external table, only metadata will get deleted. Data will still there in a table. That is the difference. Okay. Okay, so we saw partition also. So what is partition? Like everybody able to remember what is partition?
If you want to use an aggregation, aggregate table, then
placing data as a files in separate folder.
Correct. So partition means it is creating folders, and then inside it will store the particular data. So that's what we are calling it as partition. That will create folders internally. If let's say if we create a partition monthly, then each month it will create one more folder for each month. Inside those data will be stored. That's what we are calling it as partition. And that day we didn't have one more concept that is called bucketing. So that is also one more performance related optimization which we need to do. So bucketing is nothing but it is the same way like we are using in other technologies only. Bucketing is nothing but it will hash the input and then it will store the result into the respective memories. For example, just for example, let's say we have this guy like 10, 20, 25, 26, 27. 29, 46. Okay, this is our input, and we want to store this into some memory. Okay, so for that, what we need to do is we will be applying some hash function. Okay, hash function will apply. Hash function is here. I am assuming it is a modulo of 10. I am just applying the hash function here. X modulo 10. So whatever the number it is coming, I will just do the modulo of 10. With the result, I'll store it in that particular memory space. So this will be a memory space 890. Okay. So first 10 is coming. So 10 it's a result of 10 modulo 10 is 0. So I'm storing 10 here. And again 24 is coming. 24 modulo 10 which is 4. I'm storing 24 here. And then 25 is coming. 24 modulo of 10. X modulo of 10, 25. So 25 I'm storing here. Again 26 is coming. I'm storing it here, 26. And then 276. That is also modulo of 10 is 6 only. So what I'm doing is I'm storing after this 276. Okay. And then what I'm doing is 29 is coming. So I'm storing it here, 29. And then 46. So this is just a way of storing the data using the hash function. This is exactly what is mean by bucketing. So what is the need of this, or what is the requirement of this is we need to get store the data as spread as possible, so that it will store across all the memory location. So if we want to again fetch the value, now we stored the value. If somebody wants to fetch the value, let's say 276, somebody wants to fetch the value 276, then what they will do is they will apply the same hash function and then it will give the result of 6, so that the system knows it is there in the memory of 6, so that it can easily directly go into the position and then it will read from there. Understood? So this is basically how to apply hash function and how to store the data in the memory location. So exactly this is what happening in the Hive bucketing also. So in Hive bucketing, if we see the Hive bucketing, there will be one hash function. So here the hash function will not be modulo of C or nothing like that. It's a modulo function is defined by Hive itself. So that modulo function, that hash function will be run on top of the whatever the data is there, and the result will be stored on the particular buckets. So everybody is clear till now what is bucketing?
Yeah.
So fine. So here we saw it will be stored in the memory location, right? 0, 1, 2, 3, 7. We are saying it as it will be stored into the. I'm just muting all. Okay. So here we have seen everything is getting stored into the memory location. But in terms of Hive, what is memory location? If we took this Hive does not store anything in memory location. It is a folder concept. It's stored in files in folders and files, right? Folders and files. So that means if we specify bucketing, it will store, like we can specify while creating the table itself, we can specify how many buckets it will have. So let's say if we specify 64 bucket, it will create some hash function according to that, and then it will store those data into that many files. Okay, this all will go into one file, separate file. This all will go into another file. This go into another file. This will go into another file. Here we are switching it as a memory location in other systems, but in Hive we don't have as such. It is everything going to store as a blocks inside the SDFS. So if we mention bucketing and if we mention the number of buckets in a Hive, what will happen is that many files will get created. So if you want to access some particular record, it will directly go and fetch the file. That's what make it as easy. And one more difference between partition
is all the files created in a particular folder, or just it will?
Yeah, it will get created in a particular folder only. This is multiple files in the same folder.
Okay, do we need to mention the file? Do we mention the folder path while generating the table, or?
We don't need to mention. If you partition and bucketing, it will automatically get assume like each partition will have all the 64 files. Data will get distributed among that.
Suppose while creating a table, if I am not mentioning the number of buckets, so will it take any default bucket size, default numbers, or?
Default, I am not sure. We will always mention 32 or 64. I'm not sure whether it will take the default bucket, because this is the syntax which we always give. How many buckets we need to specify. I'm not sure. If we did not give, I'm not sure. I need to check that one.
Okay.
Yeah. So, okay, but the concept here is partition versus bucketing. Partition, it creates a folder, and bucketing creates the files. So in order to partition to work efficiently, we need to give the common column. At least some kind of commonality should be there, because partition will get created folders. Okay, each folders will get created, but in order to bucketing works perfectly, we need to give the most granular column, such as like our user ID or username. Because the more it is gets spread on the files, the better it is to retrieve. So that is why that's the difference between partition versus bucketing. So partition, we will always give month or year, or sometimes if daily data is used, 1 GB daily we are getting, we can use date as partition. versus user ID or username should be given as a, usually primary key will be given as a bucketing point, because then that's how it will get easily spread among the data. So here we have, for example, we have 3 partitions on one table. If we mention 32 buckets, 32 files will get created on the loading data. So data will be spread across here. So we'll just try to create one bucket and we'll just see how data is stored and what is the result. And let's check, before that let's check the Hive. Yeah, so everybody's clear till what is the bucketing. I think somebody joined recently, I guess, right? I think Shankarji and somebody joined from mobile. Those who joined, just we saw bucketing. Bucketing is nothing but it will apply the hash value in the input value and then it will show the results. Okay, we entered Hive, show databases. Okay, so you can join the computer also. Okay, so let's use this September. That is the DB which we are using. Show tables. Select star from user info part. Okay, we have some data. So which is cool. Then we'll start creating a bucketing from here. What we are going to do is we are creating one bucketing table. So same, we are doing partitioning. On top of, we are adding the bucketing based on the user ID. Okay, so user ID will be split into buckets, and let me give 64 or 32 buckets only. Okay, and then we are giving a location also. Before starting that, we need to enable the Hive enforce bucketing is equal to true. That is the property we need to set before enabling the bucket. Default, the bucketing is disabled for everywhere. Why the enter is not okay? Okay. Okay, it is showing some issue. Let's see. Cannot process Hive enforce bucketing set. Okay, I forgot set. Set Hive enforce bucketing is also true. Okay, now it is set. Here also let me add. Now let's create this one. Okay, the table is created. Now let's insert the data from user info itself. Like here, what I'm doing is I'm using the user info table as a base table. From there, I'm doing the bucketing of the next level, next layer of the table. Just let's see whether we have the data in the user info. Select star from user info ext. Okay, I'm using this one because we don't have user info in the current thing, so we'll use user info underscore ext. Dynamic partition strict mode, at least one partition column. If you can see, we don't have dynamic partitions enabled, so we are again doing this. So if we want to make it always non-restrict, we have to like change in XML files, Hive configuration files, then it will always be true. Launching jobs. Okay, it's creating. First job is getting executed. So what we are doing right now is we are inserting from our base table into bucketing table. And if you can see, there are number of mappers is 1 and number of reducers is 32. So why 32 means that many buckets. So that many buckets means that many output files we require. So that is why we have the reducers as 32 that is mentioned, because the hash function will be applied in each part, and then the result will be stored as a separate file. That is why 32 reducers are running. But the mapper is only one. So it will take the mapper, it will complete. After that, 32 output file will get created in the result output directory. So here, let it run. I'll just show you what we are doing. This is our Hive, and this is our external table. We have one table that is called user info. Okay, user info. Here we have all the data directly. Data is there already. Data, everything is there. Okay. So from here, we are creating one more table, which is called user info. User info bucketing something we are again. Okay, here from here we are creating this table. What is the structure of the table is, here we have partitions as date and inside that is more clustered by, which is bucketing as user ID. So 32 files will be there at each partition. Okay, so that is the difference between this table and this table. From here we are taking the table from data from this table and inserting into this table. Look, everybody understood the command what we are doing? This is a command for that. Yes, Sankarji and Salonji and Ganeshji, Anandji.
Yeah, yes.
And Anbuji. So here it will take a lot of time because it is going to run 32 reducers. Even though we don't have a lot of data in that, it will still execute all the 32 executors to complete whether it has any data or not. So once that is completed, we will be able to see 32 files created in the target folder. So is there any other way of creating bucket? So why do we need to go for this way? Can we directly insert the bucket from outside? As far I know, it's not possible. We always do the layer 1, layer 2 approach. We call this as a layer 1 table. Layer 1. This will be layer 2. Layer 2. So from layer 1, we will get the data from the outside, which is from other doing. We can do FTP or scoop, FTP, or we can do scoop to bring the data into HDFS. This is our HDFS.
Arumugam?
Yeah.
One question. When you talk about the external table, right, the layer 1, so it is outside the HDFS or it is where it is?
Yeah, it's outside the HDFS. I'm talking about RDBMS, such
Okay.
RDBMS and file systems.
The user info data is in the file, which is a layer outside the HDFS.
No, user info is inside. Like this is outside. Like this RDBMS is right.
Okay.
We will bring the data to HDFS as a layer 1 without changing the data, without changing any formats. We just put the data in a layer 1.
Okay.
So after that, this is a layer 1. After that, we were changing we are doing our changes and whatever the table we want to do, we'll create the layer 2 as a bucketing layer or whatever we want to. We'll optimize the table and store.
So the layer 1 structure, how we have to specify?
It is an exact same replica of RDBMS.
Okay, so you don't have to specify any structure, just copy as a flat file.
You can, but after that, what if you copy that as a flat file? Then what we have to do is you have to give the schema to it, right? In Hive.
Right, right.
So for that, you can do it manually, or if you simply scoop using the Hive export, it will create the schema for you and it will create the Hive table for you in Hive. So that is also one other way of doing it.
Okay.
You can do it either way.
So
But if
in
you have
school,
flat
you have to
file,
use it
then
as a
yes, we have to give.
Hive.
Yeah.
Okay.
Yes, you were asking something. Okay, it's completed. 32 mapper is completed. Let's see what is the output folder or partition contains. So it is already partitioned.
The schema what we are creating, is that a Hive meta frame or?
This is a Hive table. We created on Hive external table, right? We created a bucketing table. This is a bucketing table. This is a folder where the Hive results are stored. This is a folder where the Hive is looking for the data. So we are looking into this and how the file is stored. We are just checking how the file is stored in this one after performing the map_reduce function. We just did this like layer 1 to layer 2. We just ran this query for that, and we are just checking how the data is stored in the particular format. Okay.
Okay.
So this table, what we are doing is we did a partition and also bucketing. Partition also we did, and bucketing also into 32 buckets we completed. So initially we saw till that it is inside, it is having a folder till here, and inside that we just went into one partition and see that is having 32 folders, 32 files. So if you see, under each partition there are 32 files will be there, because that many buckets we've created. Got it? So everybody got the idea what is bucketing?
Yes. I have one question, RJ.
Yeah.
Actually, when we are using this one Hive, will it help to use only for structured and and semi-structured data?
Hive is mostly used for structured and semi-structured data only. If you want to play with unstructured, we need to use another like some other like scripting language to make it as some kind of structure, then put it into Hive. Then only it is more useful.
Okay, right. Okay. Thank you.
And also, if we are going to play with some unstructured data, at any point we will be having some kind of structure. We need to get some kind of structure out of this. Then only we will be able to use it for our purpose, right? So that also we need to apply. Then we can get the data.
Okay. So when we are trying to extract from unstructured, then we need to use some scripting like Scala, Python, like that, and MapReducer like. Then only we can do it, right?
Yeah. Then you can store it into Hive, and then you can get the most out of Hive.
Okay. Do we need to store it in Hive or HBase?
No. If you want to go for unstructured, then Hive or just files should be enough, because you will not be able to store unstructured into HBase. HBase needs some structure actually. You can use, if you have JSON, XML, those kind of things are called semi-structured.
Yeah. Yes.
That will work perfectly with HBase or NoSQL database. If you go for 100% like unstructured,
Unstructured.
then NoSQL will not be the best case for that.
Okay.
So
Okay,
how do
thanks.
you handle like unstructured in RDBMS?
No, RDBMS we cannot able to manage.
Even if
Unstructured.
you can manage, you will store it as a blob, some data type, right?
Yes.
XML will
Yeah,
store it as
yes.
XML
We need to
blob.
store it.
Yeah, you will store it as a blob, and then when you want to read it, then at the time you will try to write some regex expression to read it, right?
Yes.
So that is somehow that's possible with the RDBMS. So the same way you have to do in Hive also. If you have some unstructured data, that is the way you will handle. But again, there you have a limitation of like it will run for a long time, and there is not going to be much of the use. So instead of that only, currently everybody is before that itself they are doing one level of scripting and removing whatever the data is not needed and putting it there.
Okay.
So that is the way it's working, because still you can store the same way in blob. It's not blob in Hive. The string in Hive you can use the same way, but it is not properly used. It is not a correct way to handle.
Okay.
That is the only difference.
Okay.
But if you have XML and all, you have a function. XML, JSON, you can store it in same way. It's as the same. I think Oracle also has function, right? You can store the XML in one separate field, and then you can read it as XML and do operation on that. Same is available in Hive also.
Yeah.
Same is available in Hive.
Okay.
Okay. So these are some of the uses we will be doing for optimization purpose. How to store data means, so that's a thing. We will be doing the partition, and then inside we'll do the bucketing to store the data. And one more layer of operations we will do, that is called file structure. That we'll see it. File structure.
Aru, one question.
Yeah.
So you told about the bucketing and the partitions, right?
Yes.
But we'll specify explicitly. Bucketing also we are specifying explicitly how many buckets we require, or it is decided by the
bucketing. We are only specifying here. We are specified here 32 buckets. That is why it created 32 files.
Okay.
And bucketing, we cannot specify random numbers. It has to be the 32 or 64 or 256. No, it has to go into the multiples of 32 only.
Okay.
Maximum 512 we can go, I guess. So we will not be able to randomly give some number for buckets.
One file will go under one folder only, right?
One file or one bucket?
No, one file I'm asking. One file will go under one folder with 32 buckets. Is that right?
Correct. Oh, the range of files, like whatever the function is being applied on that will go. See, if you see here, the 12 is our partition, right? Inside we have some record. Let's say 5 records. On the 5 records, that will be applied on the hash function, and those results will be spread across the 32 files, and it will get stored across these files. So if you see here, a lot of things are 0, and this is 32. This file is having 32 bits, and this is 20, this is 17. So only 4 records is split across these 3 files and stored based on the hash function it ran. So same way it will do for everywhere. If it's some other files is coming, it will store here, something like that. So that's how it stores.
Some other file comes, it will store in a separate folder, right?
No. If it is, if the partition is same, then it will store in any one of the file only.
Oh. So then it will when you say some other file, some other files with the same structure.
Some other file?
With the same structure. Is that right?
Some other file with the same structure. No.
With the same structure.
1 minute. See, it is not the structure, like this is one table, right? This is under the same table. So how will you store the different structure in the same table?
No, my question is, I have an employee file. It has 5 columns. For that, we are defining this bucketing and everything.
Okay.
If I have a customer file, that structure schema is altogether different. Like this, whether it will any files comes, it will save under the based on the partition, it will save, or the folder and partition will be created different for different files.
Okay. If you store employee files in employee folder, you will create a separate. If the file, let's say you have employee file, you will create a separate table for that, right? Employee underscore info.
Correct.
Employee underscore info you will give. For that, you might give the location as user Cloudera /emp info, right? This is one
Right.
separate. This is separate table, and this is separate the location for that. And again,
Right.
you are having one more table which is called customer info, right? That you are going to have some other location for that, right?
Right.
Cloudera info. So this is a different table and different section that will stored in this folder. This data will get stored in this folder.
Okay.
So you can do bucketing here also. You can do bucketing here. You will do like two tables are different structure, right? It is same like RDBMS. That is
right.
The structure is different structure.
Okay. Well, what you meant is, if the same file comes for a different day, then it will be
correct.
That
Exactly. Correct. That's right. Yeah. So that's fine. Let's move on. So deciding this is an important thing, because like bucketing and partition, that's this is a concept. That the concept wise is nothing much. That's the same thing it will do. Once you understand how it works and all, you have to decide what is a partition column and how it should be done, and what is a file, how much file you are receiving, what is the size, and whether what is the result you want to do. Like based on that, we have to decide that, like how many loads we are doing, whether we are doing monthly aggregation of queries more or day aggregation. Based on that, we need to decide bucketing and partition in the project. That's how we will do. And these are the creation of tables, external table, internal table, and all. And Hive is a schema on read. Okay, so it shows, yeah. So let's see what is schema on read. So the data is there here, right? Let's see. Hadoop FSLS /user/ so info. So this is one folder. Let's see what's in there.
Not from the external table, external bucketing table. I want to.
You want to do what?
External bucketing table.
You want to see the data?
No,
You want to see the data in the bucketing table, G?
Yeah.
Okay, so this is the same, right? This is what we've seen, right? This is the bucketing table. This is a bucketing table. So we have 3 partitions, and each partition we have buckets. Buckets will be created in. This is a folder, and inside each folder we have 32 files. Any questions in this?
No.
Okay. So it just creates 32 files. That's it. Because we mentioned 32 buckets, it creates 32 files, and it will just puts whatever the records it puts into the respective files. That's it. So now I'm just trying to demonstrate some other things. Like we are saying schema on read. So if the currently whatever we are doing, we are matching the schema with the file, right? Hadoop FS cat. So till now, whatever the example we have seen, we are exactly matching the schema with the data, whatever we have, right? So this is data we have. So here we have the CSV file, and we are matching exactly the schema with the table. So in that case, what happens is, short tables, select start from user info ext. So that's why the data is getting correctly matched. Fine. What if we don't have the proper schema against the data? What if we don't have the date in some other column or something else? What will happen? Any idea? Series desktop. We'll just try to change the file userinfo.txt. I'll just add one more folder. A 2020, A 2020, and test 2016 05 23. So now what will happen? So I'll just push the data. So I created one wrong file, and then I'm pushing into Hadoop /user/cloudera/ okay, I'm just putting the data on top of it. User info ext. So the data is already there. That's why I'm doing the force option to overwrite the data. No such file directory. Okay, there is something going wrong. User info. Okay, it's user info only. Okay, again user info. XSLS. Okay. We need to mention the file, right? Target file I did not mention, that is issue. Okay, now let's put it. Okay, I just cat so now one line does not have the proper schema. So what will happen? It did not show me any issue because Hive is not schema and right. So now if we read, what will happen?
It will drop the row?
No, it will not drop the row. Okay, we'll see. Everything will see. If you see, everything is properly aligned. This is it. Everything will be shown in only one first column itself. Schema, and the other three columns is showing us null because we did not specify the comma here, right? So that is what it happens. It will try to impose the schema while reading the file only, and if the schema does not match, it will not show any error. It will just show null. So this is what the tricky position in Hive. Always in layers, in second layer, third layer, when we are going to write queries and all, it will not show any error. It will show only null. So we need to make sure whether it doesn't show the null or it is not, the invalid data is not there. So for that we need to work some more to like validate the data are fine with the data Hive. Correct?
Okay. So I have a question here.
Yeah.
So just now you modified the file, right?
Yeah.
And put which file you modified? The one which finally created out of the bucketing?
No. I did not mess up with the bucketing file. I just working with the external table, simple external table.
External table means?
It does not have bucketing. It does not have anything. It is just directly one table is there, right?
This table is which table? The one the SIP is putting in the layer one table or the
layer one table? Layer one. Yeah, it's a layer one. So layer one table only we have nulls and all. In second layer and all, we will just remove it and do the proper removal.
Okay. Layer 1, oh, just modified layer 1. You didn't push it to Hive format. Is that
No,
right?
no, we did not. We did not. Correct. We did not.
Okay. But in the Hive format, will it do that like that? If it is particular row is not in bifurcated in a column way.
No, no. What do you mean by Hive format?
No. Layer 1 doesn't have the Hive format, right? It is just a dump of the external table.
No. Yeah, that's it. What do you mean by Hive format?
What do you mean by Hive format? Okay, however, Hive is the application deciding on this HDFS, right? Hive readable format.
Correct.
Okay. So when you say layer 1, can you go back to your picture?
Yeah, 1 minute. Yeah, sure. 1 minute. I'll go. Session information. Class notes. Yeah.
Okay. I assume the layer 1 is the scoop which is pulling into that
Okay.
this area.
Yeah.
Right. This is not a Hive readable format.
No, that's a Hive. It is not like Hive readable format or nothing. It is the same way. Hive does not have anything on its own. Okay. So it is a text format only. Here also we are having it as a text format only. It is not in this approach. At least in whatever the approach we are following, we did not change it to any format here. It is a text format altogether. Till end, it is a text format only. It may add some unreadable character to that, but it is a text format. It is simple files. Still, even in a layer 2, it is handling like that only. Hive does not have its own format or something. No, it's not.
Right. So that means if you have a schema structure, anything can be read.
Yeah, anything you can read.
Okay. So then what is the difference between the layer 1 file and the layer 2 file?
But we have created partitions and we have created files into that, which is optimized by Hive. It created these things, right? It put the data into the proper files. If you can still open and see the file, what is the data is there in this one. I think I already saw that one. Yeah, let's see it again. It is the bucketing file. Still you can see the data. It is visible for us only. Cat. It is not showed in unreadable format because it is a text format only. It just adds some characters to separate us. That is fine. But still you can see the data. It is the same data.
Okay.
Because it is text format, we are handling till end. If you change it to some other format like ORC format or somewhere, then you will not be able to read it.
Okay.
But as long as we are using text format, it's not specific to Hive storing in such a way. It is always files and folders.
Okay.
Okay.
Thank you.
Yeah, sure. So Hive is a schema on read. While reading only, Hive will impose the schema on top of the data, and it's stores schema and database and processed into HDFS, which is fine, and is designed for OLAP. So you can do the aggregation operation and those things you can easily do on top of Hive, and it provides SQL type of language querying called HiveQL or HQL. So you can write whatever we are writing the query, HiveQL, that is called HiveQL, right? So that we can write. And it is familiar, fast, and extensible. Yes, recently it is much faster. It's got up to fast, so that is fine. And some of the issues with Hive is there is not easy way to append data. So whenever we wanted to append, we wanted to do like daily load, we have to always do our approach of daily creating one file and put it in the folder and read it to Hive. That is one way of approach we can do. That is a way, because you will not be able to easily append it to one file. That is not possible because HDFS is immutable. You will not be able to edit any file in HDFS. That is a basic thing everywhere. Once you put the data into HDFS, no, it is we will not be able to edit the file anywhere in HDFS. We have to create new file then only. For example, just now we wanted to change some data for the file user info. What we did is we edited the file in Linux and then we pushed it. Correct. We used the command put -f to overwrite the file in HDFS. Because we are not able to edit the file in SGFS, we did the approach. So understood? This is a thumb rule, as for now at least. We will not be able to edit anything in SGFS. Got it, everybody? Everybody clear till now?
We cannot edit
Yeah.
anything.
Yeah. Yes.
Yeah, tell me.
We
Somebody else.
cannot edit anything in HDFS means either we have to create it as another file.
Yeah, you have to create as another file, or you can do it. You can delete and put some other file into this.
Okay.
For example, we have user info.txt in SGFS. We will not be able to edit, but same we can do it in our local, like Linux. Okay, so future works that's being done is views is currently available. Views are available in Hive, so it is not a future work anymore. We already have views, and more future work in mail list. No, those things are already available. Currently, the work which is being done for Hive 2.0 is the metastore is being moved to HBase. The metastore currently we are doing RDBMS, so which is not a proper thing, because if you want to go for big data, you need to have RDBMS. No, that's not a way it should work. So they are slowly moving into HBase as a metastore. Currently, the developments are being done. I think in 2.0 it will get released. So Hive is mainly used in most of the projects. Like it is used in many projects. And for example, what could be the major use cases? So some of the use cases are, you have large amount of logs. Okay, so entire log. Previously, if you want to, let's say you wanted to find out some of the events that is being done on the logs. The logs, which I mean, it may have some kind of JSON data or unstructured, or it is a proper structured CSV data. Anything can be there in logs. There are different logs for different applications. Some could be application logs. Application logs can be there, or running logs, system logs can be there. So there are a lot of logs. So if you wanted to find out or done processing some of the logs, previously what we were doing or what is the approach is, we have the logs, then we write some kind of programs, which means we need to write Java code or Python, something to like analyze the logs, to analyze and then report it, and we need to show the dashboards and those things, right? So these are the approach. This is logs. So currently what's happening is, instead of writing the Python code or Java code in MapReduce itself, what's happening is they were putting everything into SGFS and creating external table. From there they were writing the query. HiveQL to analyze the results. HiveQL to analyze. So if the data is too much of unstructured or something, here they are having one more layer of data. So here they just using Java or Python or any shell scripting to make the data so somewhat structured, where Hive can be easily used. So here they are using Hive, Java/Python/shell, and then the data is being put into Hive. This is Hive. So from here, they are writing HiveQL to get the results and to remove the nulls or whatever they want to do. They are doing. So why it can't be done in Python or Java? No, it can be done in Python and Java itself also, but the complexity is less, but the development time here is less, and a lot of data can be processed. So development time is very, very less in Hive. So that is the reason why this is happening. This kind of structure is happening. And also the data warehouse, you can just change the data and put it there itself. You can query and you can expose this to next system. The underlying downstream you can push. Downstream can easily access the HiveQL because you have structure and it is a warehouse. It just stays in SGFS itself. So these are the main use cases what's being done mostly. Another thing is text and data mining, which is training data. And this part currently this is being moved into, like, a lot of the implementation are happening in Spark SQL. Spark SQL. There, a lot of the text data mining, machine learning things are being started to implement. So Spark also can easily get the data from Hive, that we'll see in the Spark class. And then mostly business intelligence things and advertisement, all the SQL things and spam detection, that is also very simple use case in Hive. So that also you can easily get and put it. Right. So one of the example I'll tell you, one use case what is happening. Let's say there is a banking client. So the banking client, they have employees. It's a very big bank in US. So they have around 2 lakhs employees. Okay, around the globe. And if the employee thinks and they wanted to, they are only entering the data into the system. So if any one employee wants to create some account, and then he transfers, because he is only handling the accounts, he transfers the data to his account. So somehow this can happen inside the company. So the employee can do the fraud and they can easily transfer the money to them. So for that, what they are doing is, they are comparing this 2 lakh employees with each month they were like new accounts are being created and old accounts are there. That is being around, it comes around 2 lakhs or something. It is, I'm not sure about the exact number of the accounts that has been created, but it can come to lakhs of amount, it will come new accounts. So this 2 data set will be compared. All his information, the employees, all the information, whatever information he has, everything will be put into one system. And then this will also be put into one system. These 2 things will get compared, and whether the data or any layer of the information is matched. He might have given the same proof or something. Based on that, there will be a matching number will be given, like 1 to 10. If the number is 10, the employee likely to create a fake account and create or do some fraud of things. So that will get alerted to the higher officials, and that will get he will do the furthermore analysis on the account whether the any fraud things are happening or not. So the main problem here is comparing 2 large data set. So what's happening is, this data is also fed into Hive. This also fed into Hive. Hive means HDFS. These 2 were getting compared. Previously we were writing MapReduce jobs for this. This was done in MapReduce jobs. Whatever we wrote in the initial, we wrote MapReduce jobs. Why MapReduce jobs we wrote? Because it is a complex comparison. Like each fields, there are a lot of other comparisons. So that's why we went for MapReduce. It's not a simple just compare and those things. It's not like that. We need to write a lot of business logic, whether this and this, there's a lot of business logic involved. That's why we went to MapReduce, because we can write core level of application into that. Currently we are doing it using Spark SQL to compare this, and it's faster also. So this is one of the example where we need to compare 2 large data set, and then we need to find out the result or something like that for the result. And one more main problem is, I think many of the banking clients know, it is AML, which is anti-money laundering. So anti-money laundering is nothing but you are bringing the data from one account to another account using your Pinami account, whatever it is. So those things also we need to find out. This is very like all bank accounts, all banking, every banking client, they want to implement this as a very strict rule. So for this also, currently there are a lot of Spark application that is being built. Spark, we are using HBase, Hive, and Spark application to find out where this is happening and how it can, like what is the business use cases, how it can be stopped. So these things we are writing a lot of applications currently. And as the same goes for insurance client also. Insurance client, they have different kind of use cases. The claims, whatever they are, we are putting claims, and the claims has to be approved. For that, what they need to do is, let's say you have a particular claimed for particular disease, and this has to be compared with multiple layers, like whether the correct prescription is done or not, whether this is for the lot of matching has to be done. So for that also, the initially what happened is each claim needs to be go to the doctor and someone has to be explicitly sit there and validate it. Those things, those kind of things has to happen. But currently, the number of employees, number of manual work is much, like it is reduced to very low. Like only one doctor is there and he is able to do hundreds or 200s of applications in 1 hour or 2 hours. Why? How this is possible is lot of the comparison is being already done in system itself. It's already fed into our system in HDFS and Hive itself. We are using same thing. Again, Hive only we are using. So the results only, whatever the things it is not matching, those things only the doctor has to see. So previously there are 50 members of team. Currently only 10 people are there in the team. It is an actual example is happening. So the clients are very happy. A lot of money was saved over there. So like this, there are a lot of use cases are implemented using Hive and Spark. So any use cases implemented in your project? I think Selvam a lot of, and Ganesh any similar use cases implemented in your projects or whatever you are coming to touch with?
Actually, the
No,
thing
not
is,
like this comparison.
yeah.
We just used Hive
And
as a staging area before to the database.
Before database, right? Yeah,
Yeah.
that is maybe if you, that's also happening in a lot of places. It's not entire. Everybody is not entirely leaving RDBMS and going to HDFS. It is just they are doing is in staging and those things also. It is correct. That's also happening.
Because that ours is mainly on the retail area where sales is more. So
Correct.
use Spark and database is a Redshift. So they just use this Hive as a staging area while processing incrementally, placing in HD or Hive and then pushing to Redshift.
Correct. So correct. Retail is also one of the very prominent area where a lot of things are coming. Yes, Selvam. Any other thoughts? Anybody else has any other thoughts in this project related?
Actually, our company is now only they started moving towards this kind of analytics area, and moreover, still not at they still not planning to go for big data.
Okay.
In some other departments, slowly now only they started to use some AI process and all these things.
Okay.
So maybe in another year, I'm thinking, yeah.
What is the domain? Which domain? It's a retail?
No, actually, I'm working in insurance.
Insurance. Okay. Insurance.
Yeah, health insurance.
They were slowly adapt only. Whatever the project I was working, they adopted immediately. So it is 2 years project we worked on this project. And banking, they started immediately. Like it is now currently all the banking is using Spark. They already moved from MapReduce to Spark, and the fast they are going so much. Like
Yeah, and also the thing is, a lot of insurance companies are way ahead. Only we are a little bit slow. But there is some insurance companies like already United and Blue Cross Blue Shield, Florida, using now to find out the false claim and all.
Correct. Yeah, but yeah, I'm not sure how scalable, like how scalely they are using. Currently, it started implementing in other projects also, whatever I'm seeing, coming to see. But yeah, it is much progressive as far I can see. Previously, we will not be able to do like one Hadoop job will run for one day, one night itself it will run and will give the result. Currently, after Spark evolution, we will be able to do it in 4 hours, 3 hours. That it was running for day, 1 day, 2 day, and it fails. We don't know where it is failing. We just have to restart the job only because we will not be able to find out the failure reason also. Such things happened previously, but now it is much stable and it's good. So that's still evolving.
Yeah.
That we can see.
And also recently I went to the conference. There I came to know there is one insurance company. They are using AI to identify the abuse. the wrong usages of the procedures. If they do not need to do that, but even though they are doing like that and all, they are using an AI when they are trying to find out.
Yeah, exactly. The same here also they are doing, like it is whether it is actually necessary or not. Those they are putting it into the workflow. Like it is kind of configurable thing. If it is in the workflow, if the next step has to be this, if it is not this, then it will trigger alarm or it will trigger the doctor. Then it will go for the manual, like human intervention. So such things are happening. It's not exactly AI here. It is kind of easily comparable, like the workflow kind of thing. A lot of logics have been built in this one, but it didn't go to AI in this project. Currently, that project which I'm talking.
Yeah,
so
okay.
A lot of time and people energy.
Yeah, yeah.
So where we left off in Hive. Okay, so these are the business use cases. Like if you see any data, anything warehouse, wherever, because if we take any project, there will be structured data, there will be RDBMS data, there will be scoop for sure. So if the scoop is there, like structured data is there, and automatically our Hive will come into the picture. So it's kind of inevitable because 80% of the project I see they're using Hive. So there are some other things in technically we will also see that and comparison with RDBMS, and we'll try to write one UDF, how to write our user defined function over there, and also we need to see the file structure which can be used for different purposes. Okay, so that those things we'll see in tomorrow class. So I hope any other questions in today class or any concepts questions, any other questions still?
The only one question is when we are using the partition and the buckets, right? We need to use either one or only one at a time, right? We cannot go with both, right?
No.
Because suppose
please.
While we are using Hive, so we need to go either with the partition or we need to go with the bucket, right?
No, it's not the case. We can go with both things, like bucketing or both. We can go either one also. We can go, but mostly projects will use both and bucketing, because bucketing will give you the readable faster. Like if you want to do some query, bucketing gives you a faster way of accessing the data because it splits the file into n number of files, right?
Yes.
So we can most of the projects will go for both. But if
do you have any example used both in your experience?
In my experience, yes, we do have daily load of data there, and that is being come from, it's kind of telecommunication project. So what they were, they had the like partition as date as partition. They have date is a partition, and then the ID. They have one serial ID that they have it as a bucketing.
Oh, okay. Correct.
So what is the need of this is serial ID inside. They have around 64 buckets. So it is being stored over there for if they wanted to query based on serial ID or something. If they wanted to query, then it is being somehow faster compared to the non-bucketing tables. That is why they are creating this way.
Okay.
So always bucketing field will be very granular level, like primary key or something, because it has to spread across all the files.
So we have to identify for the attributes for partitioning as well as bucketing.
Correct. We need to identify. We need to mention it.
Every day you will have a 64 folders, right? I mean 64 folders.
64 files, right?
Yeah, 64.
Date is file. Yeah, that is they are okay.
Folders and the files, right?
No, one folder every day. 64 files in that folder.
Okay.
Single folder. 64 files in that folder every day. Because of the size of the data is daily 2 GB, 3 GB, it comes some like weekends or something, data comes to 4 to 5 GB. So the split is fine for them. They are okay with the 64.
One help, can you go back to the first one? The first is 5 steps you mentioned, right?
Yeah. Where?
The steps, step 1 through 5.
Yeah.
You go back and just recap, give a quick recap.
Okay. So first,
President
create the
Intel.
external table. This one, right? This one.
No, 5 steps you mentioned in the beginning of the.
Step 1, step 2. This is a text file, right? This is step 1, step 2, or anything else?
Right. Create one the external table. Okay.
Yeah. We'll create the external table,
Okay.
and then we were loading the data into the external table. Okay. After that, this is a partition example. So what we are doing is we are creating one partition table. We are mentioning here what is a partition column and all. After that, we are inserting the data into the partition table from the table which we created earlier, like the layer 1 to layer 2.
Where we loaded, step 2, where whatever we loaded, that we are inserting into the partition table.
Correct. Again, we have seen 2 things. One is dynamic partition, another one is static partition. In static partition, we will mention the partition name and we will control what data should be flown into. In dynamic partition, we will not do that. We will simply mention the key. It will take care of itself. It will take whatever the partition column is coming. If it is a new, it will create new folder and it will insert the data into that. That is dynamic partition. In order to enable dynamic partition, we have to enable this setup in our Hive. Okay. After that, we saw bucketing. In bucketing, yeah.
Why do we need 2 partitions?
Here, right?
No. Why do we need a dynamic and as well as the static?
In some project, if you want to handle, then you can go for that. Because dynamic partition project, we will not we will manually handle that things. Because if something goes wrong, if some wrong data comes into the DS, then it will create the partition like anything. So in that case, we don't go for dynamic partition, we'll go for static partition. In project and all, we will create this as a variables. We'll handle this like *1 or 2, like that we'll handle it in our scripts. That is why we have dynamic and static.
Then the step 6.
6 is nothing but a bucketing. So bucketing also, we will have to mention how many buckets we need to use. So we can give 32, 64, 128. We cannot give random numbers, I believe. We have to give 32, 64 and 256 or 512. So those are the buckets we can give. This, how many buckets we have given, that many output files will get created inside our folders.
Right.
So that is output. We have to give the buckets based on the very less granularity, so that it can be spread across all the files evenly. So that is the reason we need to choose user ID for the bucketing purpose.
Okay.
So those are the steps for here. You can run this in your machine and see. We have put everything into this assignments. Assignment Hive. You can see the data is there. User info is there. Hive steps is there. These 2 things are important.
Okay.
Kafka. It's unwanted things. Okay. Okay, we will see in tomorrow class. I hope today class is useful and interesting. We'll see. Thank you. Thanks everyone.
Thank you.